Hello. Am I audible, sir? Am I
Am I
audible?
audible?
प्रदीप सर आवाज आ रही है हम लोगों की। हेलो। हेलो।
हाँ रविश
Hello.
सर,
Hello.
आ रही है
सर
आवाज।
ठीक है सर, बस स्टार्ट हो रहा है सर।
ओके सर।
Good
Good
afternoon,
afternoon,
everyone.
everyone.
Welcome to this
Welcome to this
session
session
on
on
application of
application
virtual
of
labs
virtual
in
labs
chemical
in chemical
engineering.
engineering.
We are
We
honored
are
to have
honored to have
Dr. Pradeep
Dr.
Kumar,
Pradeep
sir,
Kumar, sir,
Assistant Professor
Assistant
at
Professor
IIT
at IIT
Lucknow,
Lucknow Village today.
He
He
holds
holds
on
on
MTech
MTech
and
and
PhD
PhD
from
from
IIT
IIT
Roorkee,
Roorkee,
serves
serves
as
as
Associate
Associate
Dean,
Dean,
PG
PG
Studies,
Studies,
and
and
has
has
published
published
50
50
plus
plus
research
research
papers,
papers,
patents,
patents,
and
and
books.
books.
His
His
expertise
expertise
in
in
innovation
innovation
and
and
education
education
makes
makes
him the
him the
perfect
perfect
guide for
guide for
today's
today's
topic.
topic.
Let's
Let's
welcome
welcome
Dr.
Dr.
Pradeep
Pradeep
Kumar,
Kumar,
sir.
sir.
The
The
stage is
stage is
yours, sir.
yours, sir.
Thank you. And first of all, I would like to thanks REC Kannauj, especially Director of the Institute, who has given me an opportunity to present talk on virtual labs, basically in chemical engineering. So this is really a good opportunity for me that to present such a topic which is entirely uh, in a different domain. So before starting the lecture, it's not a lecture, it's just a talk which I will give you some basic concept about the virtual labs or application of virtual lab in chemical engineering. So before that, I would like to know about the audience. Uh, if most of the persons are from chemical engineering background or from different domain of this branch, can anyone? Am I audible to all?
हाँ सर आवाज आ रही है आपकी आवाज।
Yes, sir.
Okay. So Ravi sir, can you help me that
हाँ जी
ज्यादातर लोग क्या केमिकल
सर,
इंजीनियरिंग बैकग्राउंड?
इसमें डिफरेंट डिफरेंट स्ट्रीम्स के लोग हैं, कई डिसिप्लिन्स के लोग हैं इसमें। केमिकल इंजीनियरिंग के भी होंगे, इलेक्ट्रॉनिक्स के भी होंगे,
ओके
इलेक्ट्रिकल के भी
ओके।
होंगे। नंबर
Actually, I'm asking this
हाँ
question because if the most of the people are from chemical engineering background, then I have to
नो
take the lecture in that manner. Otherwise, we will take only about the concept of virtual lab. So I'm sharing my slide. So is it visible?
Yes, sir.
Okay,
Yes, sir. Slide is visible.
okay, okay. So okay, so um, basically, before talking about the aspect of virtual labs in chemical engineering, I would like to give thanks to the REC Kannauj and the organizer of this event, that is the application of virtual labs in engineering. So, myself, Dr. Pradeep Kumar, I am presently working as an assistant professor in chemical engineering. Bio sketch something told tell something about my bio sketch about my basic degrees. which I gained from different institutes. So coming back to our talk, so today's my talk is on role of laboratories, why virtual lab is needed, about the virtual lab advantages, categories of virtual labs, and application of virtual labs in engineering, and finally a case study that used the virtual labs in chemical engineering. And specific about the chemical engineering, we will discuss about the unit operation and separation processes, chemical reaction processes, and the ICT portal which use these virtual labs and help the student. Uh, this is the portal of MHRD which helps the student to take the help from different IITs for using their virtual labs. So today's talk is on these outline. So starting with this role of laboratories. So it is very, very important that first to know about the role of laboratories. What is the role of laboratories? Why the engineers need a laboratories? Because when a first year student came to the institute, he has to know about why we are using the laboratories, because most of the students said that why we are using the laboratories if only the theoretical portion can't be full. So it is better that we as a teacher we have to understand the role of laboratories, and this information should be carried to the or this information should be passed on to the student, that the role of laboratory is to enhance the learning outcome. What learning outcome? That whatever the theories we have gone through, that theories, the outcome of that can be understand by the role of laboratories. It is used to help the development of science. Must know about they must have a craze towards the scientific attitude, that is how the physical phenomena is occurring around and going around it. For example, applicable for every walk of life, starting from morning when we took a breakfast in the from the kitchen, the heat transfer application is there. When during the summer, when the heat convection is going on, that is a physical phenomena. And that physical phenomena, if that physical phenomena can be understand, if you have to know what the thing is going on, we must play that physical phenomena in the laboratories, and this will help to develop or to enhance the scientific attitude towards the student. These laboratories will help the student for critical thinking. They have to analyze why this phenomena is occurring, how this phenomena is occurring. The critical thinking can be developed through these laboratories. The laboratories will help the conceptual understanding, whatever the concept they have gone through. During the laboratory, during the experiment, the student must know and to understand what the concept they have gone through are these concept is applicable to the experiment. This can be this can be done through the hands-on experience when they perform the experiment. The development of science process and inquiry skill will the role of laboratory. The manipulative skill can be also be developed during. Sometimes people say manipulative skill don't be take it as a negative aspect. Manipulative means whenever you see the experiment, if the experiment is not performing well, what changes you are going to perform in the experiment so that you can get the result or proper result. That type of thing is known as manipulative skill. That is as per the practical applicability, how you are going to manage the things through the application of your theoretical aspect. This is the manipulative skill. And above all, these laboratories uh, will enhance the student interest for knowing the physical phenomena, for knowing the theories, whatever the theories has been studied in the classes. So sometimes you have seen most of the faculty members are here. We have taken up information given to the student. So the student doesn't want information. They want the practical aspect, and the laboratories will provide the practical aspect. That is why laboratories give enhance the interest in the subject. The retention of the student in science education and the ability to become independent learner. The laboratories will help the student to know and to understand only by themselves. If they have to perform the experiment by themselves, then they must understand, and they will also help the other teammates also. So they become independent learner. This is the case of role of laboratories. Now, again, very interesting thing occurs when we talk about the laboratories. A modern concept of laboratories converted into virtual labs. So there are critics. Then why we are using virtual labs? What is the use of virtual labs? If the virtual labs are there, then what is the use of teachers? What is the use of faculty members? Some faculty members said that if we are using virtual lab, then what is the need of the faculty? Faculty will give the information to the student as per their experiences. These are the critical questions coming to the various set of mind. So it is very important to know why the virtual labs are used. The most important thing that using the virtual lab means, the main important point is that when we have to make education learner centered, means the student is the prime learner, and when we have to think according to the student, then these virtual labs are very, very important. When we talk learner centered, what is the meaning of learner centered? Learner center means learning teaching time, because in this theory part is there. Apart from theory lectures, you have given certain set of time, 2 hours or 3 hours for the experiments. But if the student knows, or if he has the if he or she has the interest to learn more about the theory in terms of practical aspect, in terms of experimentation, then these labs
मैम बताओ हमें क्लब्स बनाने का क्या फायदा जब किसी को नाम देने होते हैं तब तो ये इतना उछल उछल के आती है हमें बैच चाहिए हमें ये बना दो हमें वो बना दो
Am I audible? Can anyone?
Hello? Yes, sir, you are audible.
आ रही है आवाज मेरी, आ रही है?
Yes,
हाँ
sir,
आ
yes,
रही
sir.
है आ रही है आ रही है सर।
अच्छा अच्छा, बीच में कुछ डिस्टर्बेंस था।
वो नेट का था, थोड़ा नेट का इशू था।
ओके ओके।
प्लीज
So,
कंटिन्यू।
okay, thank you, sir. So, as we talk about the education must be a learner centered. Learner centered means we have to focus on the student, and we have to make education in such a way that the student will be the prime beneficiary. And how this student must be prime beneficiary? When the student think by its own from the information which he or she gathered from the lectures, and to understand what he has or she get the information, how that can be used, or how that information can be used for the practical aspect, then he has to, or he she has to wait for the laboratory time. But if you have the virtual lab, then the student has at any time, she or he has to perform the experiment at their convenient time. So this is the learner centric approach. The second most important thing is that in this process, the learning teaching time is reduced. The student doesn't have to wait for particular slot, particular lab timing. Second most important thing is that every time the teacher has or lab instructor has to come and give the information to the student about the experiment. But in virtual lab, all the instruction is given on the computer or in the software. The only thing is he or she has to gone through these instructions and perform the experiment. So this is a learner-centric approach. And because of this, the learning time is reduced and the student learning should be faster. Another important aspect is the student finds virtual lab more engaging and interesting because it depends on their time and according to their convenience. So the students are more engaged and interested towards these virtual labs. And they make a fun out of this because each time they have to manipulate the experiment, they have to change the variable or different parameters, and through these changing the parameter they enjoy the experiment. Because in the lab, when you are doing performing of uh, experiment in the physical phase, what happens then certain parameters are fixed, and according to the environment, according to the availability of the raw material, you have to performing according to that. But in virtual labs, the availability of the parameter wants to change the parameter, according to that the outcome will come. So student make a fun and learning becomes joyful in these virtual labs. Many skill learned during virtual lab is transferable. Whatever the student learn from these virtual lab can be easily passed on to the other student, because they can, just like a what you can say, a video game, when the video person get enjoyed or get command on the video game, what he or she pass on that information to the other student also. So these skill can be easily transferable. Students learn to take initiative, develop scientific temperament, and encourage equality and equity. So This is why the virtual labs are used. What are the advantages of these virtual laboratories? For most important thing is that virtual laboratories reduce cost and time saving. Why the cost is reduced? Because this is the one time investment. Whatever the virtual lab software or whatever the fees you have to pay, it is at one time settlement. But for the physical labs, every time you have to get consumable or non-consumable item, you have to invest teacher's time, instructor time, laboratory open and laboratory, the cleaning of the laboratory. So these costs can be compensated by these virtual laboratories. The cost will drastically reduces and also the time can be saved. Second important thing is enhanced learning experience, because this is a student learning centric approach. So student can easily benefit from these virtual laboratories. So the learning experience is enhanced. Another advantage is safety. The student which has to come to the physical laboratories, they have to take care of the SOPs, standard operating procedures. They have to take care of that. And according to that, the each and every student has to perform the experiment as per the safety procedures. But here in the virtual laboratories, only you have to sit in front of the desktop, no safety features required. The only thing is you have to change the parameters. The second most important thing is virtual lab enhance understanding of process plant. This is very, very important. Because in the laboratory, what skill you are going to enhance? Because mostly as an engineer, we what the laboratories will do, we are developing the skill to the student so that these skill can be used in the process industry. But unfortunately, during our experimentation, though only certain fixed parameters can be used and that cannot be usable or that cannot be very well matched with the process plants. But during the virtual labs, you can manipulate or you can change the things according to the process plant data, and it can be easily understood whatever the thing is going on in the process plant. So virtual labs will help and it will develop the skill of what? Skill of how the process plant behaves. Whatever the parameters you have to change so that the process plant can be smoothly run. And these skill must be developed of the student, which can't be possible in the laboratories. So this is the very, very advantageous thing for the virtual laboratories. Other advantages is how to familiarize with the apparatus and equipment, because whatever the line diagram, whatever the flow diagram, whatever the equipment figures, you cannot give all the detailed information to the student in the laboratory. But in virtual laboratory, the line diagram is given. The equipment design is also given, how the equipment is shown. reactor has some other figure, column has some other figure, furnaces has some other figure. So you can easily familiarize the apparatus and equipment in the virtual lab, which can't be possible in physical laboratories. You can safely replicate unsafe and hazardous scenarios. Most of the engineering application, when you see persons who are studying hazards and they have to perform the accidents or the risk analysis they have to perform, then in physical sense there are lots of problem. They have to take some clearances from the government, they have to take care of some um, clearance from the uh, local authorities. But here in this, you can easily perform the hazardous or unsafe in aeronautical industries. Most of the accident they can virtually replicate it in the virtual labs, and for the analysis, and which must be very helpful, which can't be possible in physical labs. So you can safely replicate unsafe and hazardous scenarios in the virtual labs. It fosters collaboration, creativity, and problem solving skill among the student. If you are going to make some specific use, then you have to model the physical phenomena, and after model the physical phenomena, those equations must be solved by using the simulation program. So this will help the student the problem solving ability, the creativity, how to model the physical phenomena. This creativity comes through these virtual labs. If the person is stuck somewhere, he or she will take the collaboration with the other department also for model the physical phenomena. So these virtual laboratories have many advantages compared to the physical laboratories. So these are the advantages. Now again the question rises, because we are from different walk of life. Some are chemical engineers, some are mechanical engineers, some are only basic sciences. So how these virtual labs are helpful for each and every segment? So in broader way, these classification, or it is not a classification, you can say that the categories of virtual labs. There are various categories of virtual lab. According to that, the people are using their according to their uses. So virtual laboratories are basically a computer-based environment that simulate real or hypothetical experiments and allow users to interact with them. This is the perfect definition of virtual labs. I'm again repeating it. Virtual laboratories are computer-based environment that simulate real or hypothetical experiments and allow user to interact with them. So different categories of virtual lab which presently exist are based on design, based on functionality, and according to the purpose. Because if people from the movies background, what they will do? They have the virtual lab, they can create a virtual thing and replicate it and merge with the original one. So nowadays, if you see movies, lots of virtual things, a lot of VFX is used in the movies. These and that these must be looking like a realistic thing, which can't be exist in reality. As you see in Jurassic Park, you see the dinosaur. Is it available in reality? No, only the virtual reality is there. So these labs will help in different walk of life according to the purpose, according to the functionality, and according to the design. So here we have discussed 5 types of virtual laboratories. First one is simulation-based virtual laboratories. Second one is remote controlled virtual laboratories. Third one is augmented reality laboratories. Fourth one is virtual reality laboratories. Fifth one is measurement virtual laboratories. So one by one, we will discuss about what is simulation-based virtual laboratory. So basically, these simulation-based virtual laboratory means we will use some mathematical model and algorithm to represent the behavior and properties of the physical system or phenomena. For example, if the person is from chemistry background or from biological sciences, people are using Schrodinger equation. So this Schrodinger equation can be used for getting the minimum energy by using different software such as Gaussian, even the Gauss view, Schrodinger, Gromath, and lots of softwares are there. They are using some mathematical model. As I said that Schrodinger equation can be used in order to minimize the molecular energy of the molecule. So these are the simulation-based virtual laboratories. Here, what you are doing, the user can manipulate the variable. For example, if the temperature pressure conditions are there, you can of that on the molecular level of whatever the physical phenomena you are using. The impact of that can be very well understood or can be observed as whatever the parameters you have given to the simulation, the outcome of that will give you the how the physical phenomena is occurring by changing certain parameters. So in simulation models or simulation-based virtual laboratory, one thing is variables, that is manipulative. Whatever the variables you are going to choose, you have the freedom. Whatever the physical phenomena you are using, according to that, you can choose the variables. And then the observed outcome. If that observed outcome, you have to verify whether this observed outcome is according to your needs, or that observation is physically feasible or not. You have to take care of that. And then the test hypothesis. Test hypothesis means you have to verify whatever the things you have given to the simulation model, the outcome of that you have to verify with the validation process. At least 1 or 2 experiment you have to perform, and then whatever the data you have predicted from the model, can it be verified with the experiments? Or if it is verified with the experiment, then your simulation model is up to the mark within the certain parameter or within the certain error, if the simulation model is performing well, then you can test the hypothesis. So these are the simulation-based virtual laboratories. Some example of these type of virtual laboratories are ANSYS, Virtual Physical Lab, Chem Collective, etc. Second category comes as a remote controlled virtual laboratories. Now, as the name suggests, remote control. It means that these virtual labs use web-based interfaces to control real equipments and instruments located in remote locations. Means you are far away from the area where the system is using. For example, the satellites are there, you have modeled the things, and through that model, you are giving that data. The satellite will give the images, and the data can be verified, and you can control the things in a from the far away from far away there. So these type of labs are virtually remote control lab. User can access and operate the equipment through the internet and receive feedback through data, images, or videos. For example, Voyager has been sent 30 years back. Now the data comes in form of images, and that images can be uh, analyzed through some models, and from those models we can analyze the data, and through the images we can make a conclusion. So that images will come from light years away from the space, and we are analyzing, and these can be done through these virtual labs. The examples of remote control virtual laboratories are iLabs, Central, LabShare, and REM LabNet. Another type of virtual lab is augmented reality laboratory. These labs use augmented reality technology.
हेलो हाँ प्रदीप सर
हाँ जी,
सर सॉरी टू इंटरप्ट सर सर स्लाइड्स क्या चेंज हो रही है सर आपके उस पे
हाँ मेरे पे चेंज हो रही हैं।
सर इधर में एक्चुअली क्या है कि स्लाइड्स मूव नहीं हो रही हैं
ओके, तो कहाँ
अभी
तक
कमेंट भी
आप कौन सा दिख रहा, अब दिखा?
आ, हाँ सर अभी दिख रहा है सर
अच्छा,
वर्चुअल रियलिटी लेबोरेटरीज
हाँ,
ऑगमेंटेड रियलिटी लेबोरेटरीज
ऑगमेंटेड में कर रहा हूँ।
अच्छा अच्छा ठीक है अभी मूव कर रहा है जस्ट
स्लाइड
चेंज
शो
करिए
में नहीं जा रहा है मेरे ख्याल से, स्लाइड शो
हाँ
की प्रॉब्लम है, तो मैं ऐसे कर लूँ, दिखाई दे रहा है?
हाँ अभी स्लाइड चेंज करिए एक बार
हाँ,
हाँ अभी हो रहा है बीच में एक्चुअली क्या है कि वो रुक गया था मुझे लग रहा है
नहीं, एक्चुअल में स्लाइड शो में शायद नहीं हो रहा होगा, मैं ऐसे
अच्छा
इसको शो कर दे रहा हूँ, ठीक है?
ठीक है सर ठीक है सर
So, coming to this augmented reality laboratories, these labs use augmented reality technology to overlay digital information or objects in the real world. अब अगेन ये बात आ जाती है कि व्हाट इज ऑगमेंटेड रियलिटी? So augmented reality means we just make the things in such a way that the person who is the observer can feel the things in a reality manner. कभी आप लोग बच्चों के साथ जाइए तो कहीं पे वर्चुअल वो दिखाते हैं 3D फिगर्स, वो एक आपको चश्मा पहना देंगे और चश्मे में आपको लगेगा कि डायनासोर जा रहा है या अगल बगल चीजें हो रही है, फाइट हो रही, तो रियलिटी लगती है। तो दैट टाइप ऑफ थिंग इज नोन एज ऑगमेंटेड रियलिटी। Means in reality it is not so, but in virtually we have created the things in such a way that it seems to be a real. So that type of thing is known as augmented reality technology. So user can interact with both the real and the virtual element using devices such as smartphone, tablet or headsets. For example, मैं यहाँ से लेक्चर ले रहा हूँ, आई एम sitting at the Lucknow at IIT, but people around the this state are hearing through this uh, tablets or headset or smartphones or through the desktops by using the Zoom technology. So this is a augmented reality technology because you are seeing in reality, I am sitting over here and I am giving lecture and it seems to be that it is in front of you. I am giving you the lecture. This is augmented reality. See, so example of these augmented reality virtual laboratories are Merge Cube, AR Chemistry Lab, AR Anatomy, etc. Other category is virtual reality laboratory. So these labs use virtual reality technology to create immersive and realistic simulation of real or imaginary environment. User can explore and manipulate the virtual environment using devices such as headsets, controllers, or gloves. The example of virtual reality virtual laboratories are Labster, Nanome, and VR Maths. And most of the engineering students and engineering faculty, they are using these type of softwares. One of the category comes under the measurement laboratory. So when we talk about the measurement virtual laboratory, it means the virtual labs for measuring can simulate the behavior and operation of real instrument or devices such as ruler, scales, clock, thermometer, voltmeter, etc. Means we can make or simulate the thing and can be understood the behavior of that. For example, you can in your mobile, if you see a compass is there, a software application is there in which shows the direction where the north, south, east, west is there. So that app will help you to understand the direction. So this is the measurement virtual thing. Virtual laboratories for measurement can also provide feedback and guidance to learner on how to perform accurate and reliable measurement, how to interpret and analyze the result, and how to report and communicate the findings. Virtual laboratories for measurement can enhance the learning outcomes and the skills of the student in various disciplines that rely on measurement such as physics, chemistry, engineering, etc. So this is the use of measurement virtual laboratories. Now these are the certain categories of virtual laboratories which the people are using nowadays. Now, because we are engineers, so we have to think how the virtual labs helps the engineers and how the virtual labs are applicable to the engineering application. So the application of these virtual labs in engineering will help that it helped in computer generated environment, offers students and researchers the chance to conduct experiment, analyze data, gain hand-on experience in a digital setting. there are different software, various software nowadays available for understanding not only at the molecular level, but at the macro level also. You can perform the experiment, you can perform the changes in parameters, and you get the desirable outcomes without spending a penny on the consumable items or non-consumable items. If once you can get the desirable result, you can easily validate the result by performing a single experiment, not performing hundreds of experiments. An important difference between the experimentalist and the theorist is that theorists only think about the theory, a hypothesis, whereas the experimentalist believes in the experiment. He or she perform hundreds of experiments, hundreds of run, and through that, the outcome of that, through that outcome, they are going to get a conclusion from that, and the hypothesis can be validated through that experiment. But nowadays, through these virtual labs, we can validate the result without performing hundreds of experiments, hundreds of run through these virtual labs. Experiments performed in virtual laboratories are way of simulating scientific activity that typically take place in physical laboratory settings. Virtual lab simulations have transformed the way students interact with complex concepts and experiments. So, these are the general applications of virtual labs in the engineering. Now, as my topic, I am coming back to my topic, that is application of virtual labs in chemical engineering. When we talk about the chemical engineering aspect of virtual labs, first thing is we have to know what is chemical engineering. So, since most of the people are not from chemical engineering background, so I'm not discussing about most of the chemical engineering aspect. The only thing is that to the better understanding, chemical engineering means we have to define the process. What is process? Whatever the industrial process is going on. For example, we have to make fertilizer, and that fertilizer, the raw material of that fertilizer is ammonia and CO2. When ammonia and CO2 mix together, they form a urea. Now, this is a simple process. To carry out these process, the role of chemical engineers is there. To carry out these operation, it requires unit operation and unit processes. And unit operation means we have to take care of the heat transfer, we have to take care of the chemical reaction engineering, we have to take care of the mass transfer, we have to take care of the transport phenomena, we have to take care of the reaction engineering, and so on. Lots of unit operations are involved. But when we perform virtual labs in chemical engineering, then these virtual labs has to take care of the chemical processes. Now, basically, in performing the virtual laboratories, four segments are prime importance. First segment is the person should know the understanding of chemical engineering. Second important thing is the person should know about the chemical process, because once you know the chemical process, once you know the chemical engineering, then you can apply those theoretical aspect to the virtual experiments. And these virtual experiments will help through the simulators we can simulate or perform the processes and we get the desirable result. For example, there are many flow sheeting softwares are there. For example, a very famous one is Aspen, in which you can make a flow sheet of the process and you can change, you can give the raw material and the final output you will get. You can simulate the whole process through the Aspen. Whatever the unit operation you require to carry out these process, you can simulate it, you can give in the performing the experiment, and you can validate it and you can get the simulation result, and whatever the result you get, real experiments, not only at the laboratory level in the engineering colleges, but also at the industrial level. So as I said that unit operation, so specifically there are so many unit operation, but the most commonly used unit operation is separation processes, in which distillation, liquid extraction, absorption, adsorption, and ionic exchange are process is used in not only in the industry but in the laboratory or pilot plant study also. So in these operation, vapor liquid or liquid equilibrium is very important. You have to make the vapor liquid diagram or liquid equilibrium diagram, so that to understand how the separation will take place. So these unit operation, these data will help if these data can be generated through the virtual laboratories. When these virtual laboratories are not there, we use some standard equations such as real gas can be described through viral equation. Real liquid can be gone through this thermodynamic aspect of these vapor liquid can be understood by unifact method. So there are so many equations, there are so many models, and to get the data, we have to give the data or these parameters to these method or these model equation, and you can get the final outcome. But through these virtual labs, you can easily can get the or extract the data. One of the specific process, that is chemical reaction process, because most of the applied science persons are for or the industrial background person, they know that they in chemical reaction the kinetics is very important. To design the reactor is very important. Operation of the reactor is very important. There are so many things. Then how to perform, how to get the reaction kinetics? Because initially what the person or the what the academicians will do, they have to perform the experiment. From the experiment, they will collect the data. What data? Concentration versus time data they have to collect, and then they plot it. And from there, they derive the hypothesis through integral analysis or through differential analysis. They can fit the data in certain equation. If that data is fitted, then they conclude that the reaction is of this order or this kinetics. This can be mathematically solved where the simple equation is there. What happened when the equation is of ordinary differential equation, partial differential equations? So as the mathematical equation becomes complicated, people are using commercial language such as photon codes for solving these equations. After that, people are using MATLAB or Polymath. So many codes are available. Through that codes, we can solve these equation. But what happen if more complicated equation will generate? Then again, calculation time is increasing, computational time is increasing. So in order to avoid those things, we can simulate those results by using different softwares. As I told you in the initial, when I started the lecture, that Gaussian is using. Here at the molecular level, how the molecule to molecule interaction is going on, how the molecule collide with each other and what product is formed, you can easily analyze it. And at the molecular level, you can get the thermodynamic results also. What is the entropy of that, how that gives free energies, you can easily get from those software. So in the end, I am just say that virtual labs not only helps the engineers, but every walk of life can easily will play with these will play these parameters in the virtual labs and get the result accordingly. And this will help the student in order to understand the physical phenomena, what physical phenomena is occurring around us. That can be very understand through the help of these virtual labs. So in the end, I will suggest uh, some virtual labs. If you see this slide, especially I'm just focusing on chemical engineering. So these virtual labs are initiative by Ministry of Education through ICT portal. A chemical engineering lab is provided by IIT Bombay. Chemical process dynamic laboratories provided by IIT Kharagpur. Process control, reaction engineering and unit operation lab is provided by NIT K Suratkal. Virtual mass transfer lab is provided by IIT Guwahati. The faculty as well as the student will take the help from these websites and will help the student to understand the process, to understand the experimental process, to understand the theoretical aspect of the process. So in the end, I just say that these virtual labs are very beneficial, not only for the student, but the faculty also. So in the end, I just say thank you to all. Just whatever the thing comes into my mind, I just throw it to the all the sitting over here. If you have any queries, then I will.
Thank you, sir. Thank you for an insightful
Insightful
session. We
session. We
really
really
appreciate your
appreciate your
time and
time and
knowledge.
knowledge.
Thank you
Thank
to
you
all
to all
participants for
participants for
joining.
joining.
Have a great
Have a
day.
great day.
Yes. Any participant have any question? Please ask.
मैं इसलिए बोल इसको चलने देना है
Okay, I think
Okay, sir.
no question
Okay,
come.
sir.
So thank you very much for.
Thank you, sir. This is a very informative session related to chemical engineering and also very important for the chemistry lab point of view for the different engineering colleges. Thank you, sir.
This net problem is there.
Yes, yes, sir.
Okay. Thank you, Rajiv ji, and thank you to REC Kannauj that they have given me a chance to share my thoughts about the virtual labs. And really, I am very much, I will really appreciate the initiative taken by your team and REC Kannauj. Thank you. Thank you very much.
Thank you, sir. Thank you. Okay,
Okay.
sir. Okay, one announcement for all participants. Uh, we will put the assignment number 1 in the WhatsApp group. So all participants will submit it by tomorrow. Uh, we also provide a Google link, so you can upload assignment number 1 through the Google link. Okay, thank you all.